This video is going to go over graphing exponential functions / equations. So there are two ways that you could see an exponential function. The reason why it is called an exponential function, the key word is the word exponent, because the exponent of the function is actually a variable instead of a number. So typically when we see exponents, we see like x to the fifth, so our exponent would be 5. However, with exponential functions, the x variable is going to be in your exponent. So you're going to see exponential functions in a couple ways today in this video, and you'll see them a couple different ways in the writing exponential equations video. But this is one way you can see it and the other way. So the only difference between these two different ways is that one is written with like an actual multiplication sign and the other one with parentheses. Now again, they both mean the same thing, so you want to be able to be flexible and see them either way. The a value is known as your initial amount, so it's what you start with. This is going to be more important for when we talk about writing exponential functions, so that's not a huge big deal for you to know that it's initial amount, but it's a good thing to keep in mind. The b value is actually your growth factor, and it will tell you by just looking at it if it's going to be a growth or decay. So if your b value is bigger than 1, so a number like 3, 7, 9, something like that, then you have a growth. Okay, so if the b is larger than 1, it's a growth. If b is less than 1, not like a negative, but like a fraction. So maybe I should bound that, right? So if it's in between 0 and 1, right? If it's between 0 and 1, so like a fraction, a decimal in between, so 0.5, 3/4, something like that, then you have a decay. Okay, so, and I'll show you what that means in Desmos. So here I have two equations. I have y equals 2 times 3 to the power of x, and y equals 2 times 1/3 to the power of x. So again, which one of these is a growth or decay? Well, but just by looking at it, remember the b value, if it's bigger than 1, it's going to be a growth. So the first one is going to be a growth. So a growth looks like this. It increases from left to right. So it starts off on the left side slow, and then it shoots up really fast to the right. So it's increasing, right? So it's growing. So that would be an example of a growth. The second example is a decay because the b value is less than 1. It's in between 0 and 1. It's a fraction. So when you have a decay, it starts off really high on the left, and then it slowly comes down. So that's the difference between a growth and decay. So just by looking at that b value, you can see, hey, what is my growth or decay here? Or what if it is? You can determine it, Okay, the new vocabulary word that we have not ever seen before is asymptote. Now, asymptote is a horizontal line, and it's basically a boundary line. So the function never touches this line. So you can also know it as a boundary line. Okay? So for example, as you notice in these two graphs, right, the graph gets really close to the x-axis. Look at this red one, actually. We'll just use a red one as an example. If you look at this red graph, right, it starts off really high, and then it starts to decay, and then it looks like it hits the x-axis. But if you zoom in, notice how it doesn't actually touch the x-axis. I can scroll over here, and I can zoom in, and notice how it doesn't touch. So that line, in this example, the x-axis, is our boundary line. It's never going to touch 0, right? It's never going to touch when that number is 0. So for example, in this graph, as you can see, this is actually a growth because it starts off on the left slow, and then it shoots up really fast to the right. Now, what would be our boundary line here? Well, what number do I notice that it's getting close to but never touches? Well, it looks like it's getting close to this 2 here, right? It looks like it's getting close, but it's never going to touch it. And that's the whole point of an asymptote, is because, hey, this graph is never going to touch this, so that's my asymptote. So it's always written as y equals a number. And the reason why is because the asymptote is a line, right? The line goes through which axis? It goes through the y-axis. It goes through the y-axis at what number? Well, it depends on the graph, right? So in this case, this would be our asymptote would be y equals positive 2 because it goes through positive 2 on the y-axis. So our asymptote will be written as y equals 2 here. Now, domain on this as well is going to be just like quadratics. It is going to be all real numbers, or you can write ARN, whatever you prefer. The reason why is because if you look at domain, which is your x values, if you go from left to right, your graph infinitely goes to the left direction, right? Because it continues to go this way, and it continues to go to the right technically, right? It's going to go up really slow. It looks like it's shooting straight up, but it's not. It's eventually going to keep going to the right and the right. So your domain here is infinite, right? It's infinite to the left and infinite to the right, so you have all real numbers. However, the range is restricted. And the shortcut with this is that you always start with a y in the front. And actually with exponential functions, it's always greater than, because your graph is always going to be greater than this number. Now, it's never going to be equal to, and here's why. So again, range is your y values. So yes, the graph infinitely goes up, right? It infinitely goes up, so it hits all of these positive y values. But will it ever hit any of these y values? No, because it's never going to go past that orange dotted line. So then you're going to say, hey, that's my restriction. So it's never going to go past the number 2. And that's another thing to note. These numbers are always going to be the same. Your range and your asymptote numbers are always the same. Now, why is it not equal to here? Well, it's not equal to 2 because it's never going to hit 2, right? It's going to be close to 2, but it's never going to hit 2. So your range would be y is greater than 2 in this case. Even if it was a decay, it would still be y is greater than whatever that number, and I'll show you why in a second. So let's go ahead and practice. We have 2 examples here. Now, with just looking at the equation, I have y equals 3 times 1/2 to the power of x. I know that this is a decay. And how do I know that? Well, this is my b value, and my b value is 1/2. Because my b value is in between 0 and 1, I know this is going to be decay. So let's go ahead and graph that. Y equals 3 times, oops, that's a decimal, times, they don't have a multiplication sign. I'll just use parentheses. So parentheses, 1/2, is it 1/2 that I used? 1/2 to the power of x. Now, if you're trying to figure out how to say the power of something, it's this button right here that I'm spamming. It's the A to the B button. That's how you would type an exponent in. So this is the graph. And again, this is a decay because it starts off high and then it goes low. Remember, the B value gives that away. Okay, so next we're going to identify the asymptote. And the asymptote, actually, without even looking at the graph, I already know what it is. It's typically whatever number is being added or subtracted over here to the right. Now, as you notice, there isn't a number there. So that means that the number is going to be 0. So my asymptote, remember, is always written as y equals a number, and in this case, it is 0. Okay, so you're like, okay, I'm still confused. So for example, if I had y equals 3 times 1/2 to the power of x minus 5. So let's say I have the exact same problem, except I have minus 5 in the back. Well, then my asymptote here would be y equals negative 5, because it's whatever number is being added or subtracted to the back. Okay, so that's how I remember it, and I find that students remember that a little bit better. So, and I can prove that to you. If you notice, it's never going to hit y equals 0. So y equals 0 is going to be basically the x-axis. So again, it's never going to hit 0 on the x-axis, so that would be our asymptote. The next thing it wants us to identify is the x-intercept. Well, this graph is never going to hit the x-axis. So is it possible for it to have an x-intercept? No. So in this case, I would not have an x-intercept. So this would be none. All right. Now the y-intercept, that's going to be where your graph crosses the y-axis. You can actually hit the graph and tap where it crosses the y-axis, and it crosses at 0, 3. Again, domain is going to be all real numbers, and your range, remember, always starts as y is greater than. So that's the shortcut there. Y is always going to be greater than, and the same number as your asymptote. So it's going to be the same thing as this 0. So for example, in this problem that I have random over here, my asymptote here is y equals negative 5, and then my range would be y is greater than negative 5. So they're the same number, and with the range, again, inequality sign always is going to be greater than for this one. Okay, so let's graph this. So on your homework, you need to graph at least 3 points. So you're like, well, how am I going to get these 3 points? Because Desmos is only showing me 1 right now. So if you click on the equation on the left here, and you hit the settings button, the little gear, if you hit the little settings, you'll see a little table pop up. And if you click on it, it'll give you some values that you can plot. Now you want to pick 3 values that you can plot easily. Now there might be a decimal. It is possible that they're decimals, because if you don't have 12 tick marks, I can't graph negative 2, 12. Like, it's not going to happen. So I'm going to graph negative 1, 6. 1, 2, 3, 4, 5, 6. Oops. Okay. There's 0, 3. And then there was 1, and then 1.5. So the graph looks something like this. Now I know it's never going to hit the x-axis, so I want to make sure that when I draw that line, it says it gets really close to it. Clearly my tick marks are super uneven because my graph doesn't even go through that point, but you get the idea, right? So you want to graph at least 3 points. Moving on to the next one. So this one, again, looks like it's really confusing. But again, we can also write this with parentheses. So this would be 4 times 2 to the power of x minus 2. Okay, so again, you can use the multiplication sign or the parentheses. Now, without even graphing, I know that this is growth. My b value here is the 2. Now, if you're confused on what the b value is, it's always going to be the thing that's next to the, or that's the exponent is attached to. So the x is your exponent here, and it's always going to be the number that it's attached to. So in this case, it is 2. This is going to be a growth because 2 is bigger than 1, this number right here. Now our asymptote, remember I said, is always going to be y equals a number, and it's always going to be that back number at the very end. So this case would be y equals negative 2. So that means our graph is going to get really close to y equals negative 2, but not actually touch it. So let's go ahead and graph it so we can see the x-intercept and y-intercept. So I'm going to go ahead and close out of that one. So I had y equals 4, parentheses 2, parentheses to the power of x, to the power of x, right? Yep. And then I have, you want to make sure that you click the arrow over so you're not in the exponential, minus 2, okay? The most common mistake is some people accidentally put minus 2 in the, some people put the minus 2 in the exponent. You don't want to do that. So here is our graph. Now again, it is a growth because again, our b value here is positive 2, so it is going to go up. So looks like we have our x-intercept and y-intercept, and those are super nice. Occasionally you will get an x and y-intercept that's decimals. Just go ahead and round. It's not a big deal. So our x-intercept here would be negative 1, 0. Remember that the x-intercept is where the graph crosses the x-axis. So it would be negative 1, 0. And our y-intercept was 0, positive 2, I believe. Yep. Now, again, I need at least 3 points. So with the x-intercept and y-intercept being a couple points, all I need left is 1 more point. So I have 2 points plotted. I got to have 1 more. So you're going to click on the equation, hit the settings or gear icon, and hit the table. And it looks like I can probably graph 1, positive 6. So let's go ahead and graph that one. 1, positive 6. Now again, remember our asymptote is at y equals negative 2. So if you want to kind of just draw a line there to note where your graph is going to continue. So, So remember, that's an imaginary boundary line. So it's never going to touch that. So you don't want to draw your graph and be like, hey, this is where it ends. Because it doesn't. It actually gets really close to that orange line, but it never touches it. So you want to make sure you bring that down if possible. Okay, domain here is going to be all real numbers, and our range is going to be y is greater than whatever your asymptote number is, which is negative 2. So again, it's going to be all of your y values greater than negative 2 because everything is above that negative 2. I want to go ahead and highlight that and make sure you are aware that these are the same. So that is it for graphing exponential functions.